The 2020-2021 season of Nat Talks is made possible by presenting sponsor the Downing Family Foundation and media partner KPBS, the public media station serving San Diego and Imperial counties. Tonight's speaker is Dr. Richard Norris from Scripps Institution of Oceanography. Dick is a paleontologist and oceanographer interested in the history of oceans. Part of his research has focused on climate history and ecosystems of extremely warm periods in the Earth's past. He also works on the impact of human activities on marine and terrestrial ecosystems. He holds a BS in Earth Sciences from University of California, Santa Cruz, an MS in Geosciences from the University of Arizona, and a PhD in Earth and Planetary Sciences from Harvard University. He was a postdoctoral scholar and research scientist at Woods Hole Oceanographic Institution before joining Scripps in 2002. Dick is an excellent speaker. You are in for an absolute treat tonight, and it is my pleasure to welcome Dr. Richard Norris.
Okay, thank you very much, Judy. Let's see, I guess we can pull up that poll again. Aha, okay. So I had asked a variety of these sorts of questions. I didn't actually know the answers to all this stuff when I started doing some research for this topic of kind of where we're going as a state in terms of the environment that is caused both by climate change and also by our own population change, which I'll talk about later on. But so for this first question, the answer to this one is actually C, D, and E, so that there are trends that will be less snowpack in the future, probably more floods, more drought in particular are the big trends there. And you'll see that later on. So then the next question, maybe we could scroll up because I can't see them all. Is there a way of doing that? Maybe I have control over that. Okay, so the second question about California trout and salmon. Now it turns out that a lot of people are right about this one, okay, doomed because the streams will get too warm. This is one of the long-term trends that'll probably be playing out by the middle of the century, so not that long from now, that there will really be problems with getting the larval fish to be able to grow because of streams being very warm. This third question about fire is, interestingly enough, the answer to this one, there's of course a whole variety of different impacts, but I was thinking particularly about the second one here, wildfire smoke becoming a particularly big problem. And we've seen this in the recent fires, for example, back in September, when Oregon was suffering with just incredibly bad air quality. And the same thing was true for Northern California over a very large region, even into Nevada. And then the fourth question here is, by the end of the century, the biggest effects on the coasts. Rising sea level is one of those things, but it turns out the really big one is storm surges, because these have a particularly large impact on relative sea level for a short period of time. The estimated sea level change by the end of the century is maybe 3 feet or 4 feet or so, but a single storm surge event can introduce 7 or 8 feet of sea level rise, effective change in a very short period of time. So there you go. That's a little bit about that. We'll talk about these sorts of things as we go along. And I guess, Emma, if you could get rid of the poll, I guess I can close that up. All right, so I call this talk Future California, and the coda here is really the key thing. If you know what's coming, you can change it. We can all change it. The things that I'm going to describe today, they don't have to happen. They are things that are within our power to modify, to get under control. Some of these things have to do with our human population and where we live. Other things happen to do with kind of where we invest, where we choose to, to go to retire. How we spend our money fundamentally. And those things all have, those economic decisions we all make have major effects on how our future is likely to turn out. Okay, so this talk, it's sort of the genesis for this, was kind of my wife asking me where we're going to retire. And So when I was a master's student, as Judy mentioned, at the University of Arizona in Tucson, Teresa and I loved living in Tucson. It was a great place, beautiful desert, high mountains with snow on top of them and so forth. And Tucson is right about here, okay, down there someplace. And so it's a little south of the hot spot. That's Phoenix, as it turns out. But if you look at what Phoenix and Tucson is going to be like in the future, it's not a great, pretty place to go off and retire as an old person, particularly because as you get older, very commonly we become more sensitive to heat stress. So this is the seasonal average, okay, how many days we had above 100 degrees Fahrenheit. And you can see that the typical in the past, was maybe a couple of months of really warm conditions. But there's these two different climate scenarios. I'll go into this in a little bit more detail in a moment. But there's the so-called business as usual scenario, which people play out, called the B1 scenario. And then the anything goes, just sort of our present trajectory is this A2 scenario. And you can see that in either case, Southern Arizona becomes incredibly hot for a long time. So that we're talking about an increase of many months, basically, of temperatures which are now extreme temperatures today. So extending out the period of time when you have really, really hot conditions. And when I learned this, I said, I'm sorry, I love Tucson, but we're not going to move there. We're not going to make an investment in Tucson because it will just be too dang hot. Okay, so that was my motivation. All right, so how do we actually predict the future? And are these predictions any good? There are basically three ways, I think, scientifically or semi-scientifically, you can do this. One is you can look in your crystal ball, and the crystal ball is actually not that bad. It's kind of based upon what happened already, and sort of your understanding of the trends towards the future. But of course, it's not a very scientific concept. There's also basic physics. You can actually get quite far with this. I give an example here. Methane is a greenhouse gas. It warms the atmosphere. Warm air holds a lot of moisture, more moisture than cold air does. And so a warm climate will have more rainfall. It will be wetter for the most part. And so that's something we learned from basic physics. It's not something, no fancy models are involved. And then, of course, there are computer models, and I've used HAL from 2001 as my example. Hopefully, we don't have dangerous computers doing this kind of stuff. But, computer models can give us quite a lot of information on where we might go. They should always be taken with a grain of salt, because if you look at different models, they have different assumptions to them, and so they may predict subtly different things. But when you start to see common trends across a whole bunch of models, that's more likely to reflect something that you ought to pay attention to. And so here's an example of that. This is a paper that was published on where the bird community is going, and this is about 60 or 70 species of birds and kind of how the bird community is likely to change in the future. And there's two different, there's a model over here called the GFDL one, two different scenarios. And then this NCAR model, also two different scenarios with different kind of assumptions built into them. And you can see that the maximum change in the bird community is going to be in these hot red colors, and it turns out it's in the deserts. So the deserts in all of these simulations, all the different assumptions that they come with, the bird community in the desert is going to be changing the most in the next half century or so. And in contrast, coastal communities or here in the Central Coast, those will have less change associated with them, according to this. So because of the agreement about the bird community changing in the deserts between all these different models, that seems like something that is plausible anyway. And I will try to give you a flavor for when things are plausible or likely or like, we don't really know. So you'll hear that through the talk. Okay, so there are two huge challenges that we face in terms of predicting what's going to happen in the future. There is climate change, which turns out to be actually not that hard to model. We know the basic physics pretty well. And so oftentimes our predictions are pretty good for the future. Turns out weather prediction is in some respects more difficult than climate prediction is, because weather prediction has all this sort of small scale local dynamics going on, and climate change usually reflects big global scale processes. The thing that is really hard to predict about the future is us. Namely our growing population, where we move, how much money we have, what we spend money on, and how much we modify the landscape as a result. So anyway, that's the two issues. And I'm going to start off with us in this talk. Okay, so here is your first poll question. So in 80 years, what is our population going to look like? So it could be the same as it is now. It's about 40 million people in the state of California. When I was a little kid, it was about, about 1 million people or so when I was born. So it has increased quite a bit. Actually, take that back, about 10 million people when I was born. But in any case, so it turns out that there are predictions that are up in that upper range, of sort of more between 100 to 120%. And again, this is something that doesn't have to happen. This is something where there are political decision making about kind of what happens to our population. And so that's something to keep in mind, and here is some examples of that. So I'm going to talk about 9 different trajectories. You can get an idea where I am in this talk based on which one of these trajectories I'm discussing. The very first one is California's population. And the black splotches all over the map of California reflect urban areas and where urbanization is expected to take place in the state. And you can see 2007, here we have 37 million people in the state of California. You can see that the population centers are typically along highways. The LA basin is gigantic, the Bay Area up here as well. And then we're not too far out of, whoops, I wanted to close that. Not too far out of 2050, and the predictions are that basically the urbanization will spread out along existing highway corridors. You see, for example, this is Highway 101 here, going up to Salinas, and this is already happening. I drive up here because my mom is up in Santa Cruz, and these little towns, they used to be little agricultural towns, are already turning into bedroom communities of Salinas. This is the frightening one, okay? If we really got to a population that is sort of in this 85 to 147 million people, here there's extensive spread of humanity into the Sierra foothills, throughout our agricultural lands in Central California, even out along I-40 and I-10 heading west out into the desert. So that doesn't have to happen, of course. There were predictions in another paper that suggested by 2050, maybe 50 million people, so a little less than this. And we're already seeing changes because of the housing costs and things like that that might suppress population growth to some extent in California. All right, here is urbanization of San Diego. This is the same thing. The urban centers are in gray here, and various kinds of protected lands are in green. And you can see that, again, we're getting pretty close to this 2050 kind of pattern where this is I-15 here, and I-15 is turning into an urbanized corridor. This is Riverside County, by the way, up to the north. So you can see that right now. It's something that is already, the spread of suburbia is taking place. And then by the end of the century, interestingly enough, we have sort of urbanization all around Camp Pendleton, and who knows what the military will do with that. But basically, Southern California becomes heavily urbanized. Oh, I should mention, by the way, as I go along, I've always put the papers that I've used here. So this is all from the scientific literature. And so I've tried to give references to all this kind of stuff. And the talk, I think, will be online, so you can go and look at that if you're interested. Okay, trajectory number 2. Okay, what is temperature going to be like? And these are various model simulations of what our future could hold. And you'll notice that there is a set of simulations for the past, the recent past, and then for the near the end of the coming century. And these are winter temperatures up here, and these are summer temperatures. And then these are so-called difference maps. So this one is the difference between that one, and this one is the difference between these two. And so what we're looking at in the wintertime, so December, January, February, you can see that today you have kind of moderate temperatures. Here's the temperature scale in centigrade over here. The interior valleys get to be quite cold, okay, below freezing. There's snow in Nevada, for example. That snow is likely to be less in the future. And you can see that basically the temperatures in the winter months are not likely to change that much for us. The total change here is sort of in the range of 1 to 2 degrees centigrade, which is moderate. And it's particularly the case along the coast. The summer, however, is where the rubber hits the road. Okay, so these hot summer temperatures, which are currently confined to the very southwestern parts of our state, become much more expansive. And you can see that the predicted January, June, July, and August temperature range is something like, here in the interior of Nevada, 6 to 7 degrees C warmer than it is today. That turns out to be just huge, huge temperature change. Even coastal California warms up by 3 or 4 degrees centigrade in the summer. Okay, so that means an increase in extreme heat. So these maps show the middle of the century and the end of the century for days that exceed the 95th percentile. What that means is today, the warmest 5% of the year is the 95th percentile. And so this is the number of days that exceed that currently hottest period of the year. And you can see that by the middle of the century that we're up to maybe a month or more of extremely hot, what are today extremely hot temperatures, may last for a month or so. And by the end of the century, we're talking about maybe 2 or 3 months of additional super warm temperatures, where the future is for several months, as warm as it is in the extremely hot days today. So that's also quite substantial effects on society and on the natural world. Okay, so one of the effects of that is on outdoor labor. And these are maps that give you an idea of the percentage change in the amount of hours that people can spend outside because of heat stress. And so by 2050 here, it's predicted that there will be a modest decline in how many hours you can spend outside, of maybe 2 or 3%, something like that. By the end of the century, some parts of southwestern US will see declines of maybe 6 to 7% of hours available to work outside. And this has already happened to us. For example, in Phoenix, they've had to shut down the airport because it just got too hot. And the tarmac got soft, and people who are directing the aircraft couldn't be outside. They just get overheated. And so that reduces outdoor labor. Okay, trajectory number 3, moving smartly along. This is precipitation. What's going to happen to rain and snowfall? Now, it turns out today that almost all of the snowfall and rainfall happens in the mountains of Northern California and up into Oregon. Southern California is relatively parched. The mountains around LA, of course, they get some rainfall and snowfall in the winter months. But basically, we import most of our water here in Southern California from the central and northern parts of the state. Okay, now, these are projections, okay, of how much rainfall is likely to change in millimeters per year for the, since 1900 up to the end of the century. And you can see that, of course, we're out here right now, and so we have a good predictive model and you can run these climate models backwards as well as forwards to predict, what things should have been like in the past based upon the climatology. But the key point is that you notice that there really isn't any change, okay? There are these black scary lines up here. They actually indicate increases in rainfall, but the majority of the climate simulations would suggest that the rainfall of the future will be very similar to what it is today. The overall precipitation's probably not going to change very much. That's good news, okay? Now, it doesn't mean, however, that rainfall will always be as it is now in terms of when it falls. So for example, these are simulations for near the end of the century that show the winter months, the spring, and the summer months in terms of the percent change in rainfall. And so the yellow and orange symbols indicate a decrease in precipitation in the wintertime. Here you see Southern California becomes drier in the winter. The present year, which is unusually dry, is perhaps in our future to become a more frequent kind of phenomenon. You'll notice that up in Central California and Nevada, the rainfall actually seems to go up in the winter months. May is not that much different than today, but then the summer is interesting because you see blue in here, which means a slight increase in summer rainfall. And this has actually also happened. A couple of years ago, we had some May and June rainfall, very unusual for Southern California, but a consequence basically of heating up the ocean out here, which is the source of evaporation that then falls on land as rain. So this slight increase in summer rainfall has, as it turns out, big ecological impacts on the state. And I'll get back to that in a little bit. Now, another very striking thing is how the rain falls. So this is something called an atmospheric river. Turns out almost all the precipitation that comes to California comes from evaporation in the tropical oceans. And this is a December 1995 so-called atmospheric river that pumped a lot of water, okay, just came out of the tropics and came piling into California and created major flooding in California. And this is a model prediction of the same kind of phenomenon happening near the end of the century. And I would not believe the dates, by the way. This is just simply an idea of how the model simulation, it can show that you can get more of these atmospheric rivers in the future. But the key point is that when you dump all this water very quickly on the state, it means we end up with more floods. And so remember that the overall precipitation doesn't change, apparently, according to the modeling, but it might come down a lot faster and a lot harder and produce more flood conditions for us. Here is the example of this, okay? So here is our state capital, Sacramento in 1862, which was undoubtedly an atmospheric river. It flooded a lot of the central part of California. It created a lake in the Mojave Desert. The rainfall just came hot and heavy. And so here people are out boating around Sacramento back in the last century. Now that probably means that parts of our agricultural lands are likely to flood in the future. The major rivers coming out of the Sierra Nevada, if they get hit by one of these atmospheric rivers, the water is going to come out of the system very quickly and create extensive flooding. So we have to be prepared for that. Okay. Trajectory number 4, what happens to sea level? And I mentioned that thing about storm surge in the intro question. So here again, we have a timeline running up to the end of the century. We're sort of sitting around in here. This is projected sea level rise, which is this black line here. And the purple bars are the range of uncertainty, in what that sea level rise might be. It's in centimeters, which is perhaps a bit confusing, but we're talking about something on the order of around 3 feet of rain, of sea level rise by the end of the century is kind of a mid-level projection. But I mentioned to you before this business about storm surge. And the problem is that if you get a storm accompanying, that just whacks into the coast, it pushes a lot of water up against the coast, and that can temporarily increase sea level a lot. So if the sea level is a couple feet higher than it is today, and you add on top of that the kinds of storm surges that happen all the time, basically, then you can get really severe flooding in the future. And so the pale blue here is the hours of extremely high sea level created by storm surges. And you can see that you might have, and this says 1,200 hours, okay, of really high sea level in a given year near the end of the century. That is bad news, because the 3 feet we can kind of deal with, but if you have a sea level rise of a couple of meters, maybe 10 feet or something like that, wow, a lot of coastal infrastructure becomes flooded in that case. This has an effect on erosion on the coast. And this is kind of a crappy figure, but this is the sea cliff erosion distance, okay? How far the sea cliffs in California are likely to retreat by the end of the century. And it's a little hard to make the symbols out, but this is in meters, and that's 100, 200, and 300 meters of coastal retreat. And you can see that up here in the central part of the coast, up north of the San Francisco Bay Area, they're predicting that maybe by the end of the century, the coastline will have retreated a couple hundred meters inland from where it is now. That's just an enormous amount of erosion. This doesn't show Southern California, but you can see these intervals where you have beaches, and so there's no real coastal erosion there. But then these sea cliff erosion events, they can be very substantial in the future. So people who have coastal property are likely to look at either having to protect it with very expensive seawalls or losing that property and having it eroded and dumped into the ocean. Okay, here is an example from our own backyard. And you can go and play with this scenario yourselves. Find this thing called Surging Seas Risk Map Zone. It's an online tool. And you can mess around with a slider over here that is the water level, okay, for Mission Bay. And so here you see the northeast part of Mission Bay. I've been working in here as part of my work at Scripps. And with 10 feet of effective sea level rise, this will flood very extensively. The high school will flood, the golf course will flood, the Deonza Boot here will flood, and so forth. And a lot of the coastal strip along Mission Boulevard as well. Now, you remember that the sea level rise is only 3 or 4 feet high, okay? So that's not the problem. Turns out if you run the slider back down here, very little of this is flooded. But the big problem is the 7 or 8 feet of king tides, which happen every year, or storm surges that add to that sea level rise in the future to create these short periods of really intense flooding. Now, the city actually did a study. I wrote an op-ed on this not too long ago for the UT that showed that a lot of the city infrastructure, the parks, for example, are of course exposed to this kind of sea level damage, the storm surge damage. And that just for the Mission Bay area amounts to about a bit over $1 billion liability by the end of the century. That is a pile of money. And that, of course, is only for Mission Bay. So the rest of San Diego is probably many other billions of dollars too. That sounds like a lot of money, and it is. But remember that that's still, like 80 years away. So we're constantly renewing our infrastructure all the time. We'll be spending a lot of money to redo things, to replace infrastructure as it wears out. And if we are wise about it, if we move it to places that are more protected from sea level rise, then we won't lose that kind of city infrastructure in the future. Okay, here's my little scenario. I pitched this to the planning department in San Diego. And this is the idea of creating living shorelines that actually adjust to increase sea level rise in the future. So this is the northern part of Mission Bay up here. This is Mission Bay High School and the golf course. And the notion is that instead of like riprap and hardscape kind of infrastructure to like seawalls and things like that, we could actually build marshes that would slowly erode as sea level rise comes up. They'd be beautiful. You could have boardwalks running through this sort of thing with bird hides and watch all the fauna. It would be a very different kind of experience than we have with our current beaches. But it would also adjust to future sea level rise. And there's lots of other scenarios like this, you know, where we could learn to live with our coastlines. We don't have to have an adversarial relationship to them. All right, trajectory number 5, snowpack. I say this, you know, that fundamentally this is one of our most valuable things in the state because snowpack stores a huge amount of water and then it slowly melts and it delivers that water over the summer months and into the fall before the next snow season comes along. So it saves us from having to build dams and having to worry too much about water storage. So here's your question. In the future, what will happen to snowpack? Okay, will there be more of it because of all that atmospheric river activity? Will the snowpack shrink because we end up with warmer summer temperatures? Remember the simulations a little bit ago. Will it shrink because there's more precipitation falling as rain rather than as snow? Okay, so it never was snow in the first place. Or is it shrinking because overall precipitation is falling? This last question or last idea is false. I'll just say that right off the bat. I've already showed you the simulations that suggest no major change in precipitation. Now, I will say that the modeling all suggests that it is number 3 on this list, that more of the precipitation in the future will fall as rain rather than as snow. So we'll just have less snow. And I'll show you that. And very good, okay, for everybody. All right, so here we go. What are some of the impacts of decreased snowpack? Well, one of them is salmon. These are fans of high water and cold water. They spawn in cold snow melt spring, fed streams and things like that. This is on the Sacramento River. It turns out that salmon really have it bad coming up, according to the modeling of the future. So this is a silver salmon here, which is the common one we have in the state. And what these are 3 different model simulations, okay? Different models, different assumptions associated with them. This is time on this axis running to the end of the century here. And then this is a little confusing. I sometimes don't like my scientific colleagues for making kind of confusing graphs. But this is, if my pointer would work, 100% up here is the proportion of having as many fish in the streams as we have today, okay? And 0, the proportion is having no fish in the streams today. And so you can see that, you know, the simulations show that we're likely to have fish, decent populations of fish in the sea or in the streams until the middle of the century. And then there will be years when there potentially could be good salmon runs, but those will become fewer and fewer into the future. And the really scary thing actually are these little dots in here, okay, the gaps where we don't have a salmon run, because salmon are typically on a 3-year schedule. So they're out to sea for 3 years, they come back in to spawn. And so if the population can't recover within 3 years, then it is effectively extinct. And you can see that in these simulations, the first time you hit a population that is essentially 0 is around the middle of the century, or maybe slightly later, depending upon where you are. That could partly be offset by hatchery spawning of fish. But fundamentally, wild fish in Sierra Nevada streams probably on their way out. And I say this is, and I'm a fly fisherman. It's hard to think about, not being able to flick a fly line across a stream, after some of our salmonid fishes in the future because it's just too warm. Okay, another problem is that our snowpack is on its way out, okay? And so this is the historical average, and the color symbols in here indicate the amount of snow water equivalent. All you have to say is that there's a lot of snowpack, okay, in the historical average. But then these are two different scenarios for the future for near the end of the century. So if things don't warm up too much, then we might end up with 40% of the present level of snowpack. And a kind of a mid-warming range is about 20% of what we have today as snowpack. So that is bad news. Interestingly enough, in southern Sierras is where the snowpack lasts longest. That's the highest part of the Sierra Nevada. And so it retains, it produces snow, and the snow lasts on the ground longest in the southern Sierra. Okay, whoops. So what that means is that storage in our dams might potentially fall off quite a bit, because we'll end up with more floodwaters. Instead of the snow slowly melting and delivering water to the streams, the water instead will be coming down as floods because it's falling as rain. And that means the dams will fill up, and then they will have to dump water because they'll have no more storage. And so then this is sort of from a California environmentalist standpoint, the idea of building more dams, I think, is almost anathema. It's sort of political suicide. And yet we will need more storage in the future. Now, fortunately, there is a solution that doesn't involve more dams. And it is this, okay? Put the water underground in groundwater storage. And there turns out that we're actually doing this as a state already. The state passed a law to finally regulate groundwater withdrawals by agricultural interests. And you can use the groundwater banking system as essentially a bank by taking some of that stream water, pumping it into groundwater reservoirs, and then removing it, removing known amounts of water, selling it into the agricultural or the city markets. And that can work pretty effectively. Now, one problem is this figure right here, okay? It says 1925 up there, 1955, 1977. This is the San Joaquin Valley, okay? The ground elevation through time. So turns out in 1925, the ground level was up here. In 1955, the ground level was here, and here's 1977. I have not looked to see if there's a similar map or similar figure for today. But basically the problem has been that we've been withdrawing too much water and it has caused the groundwater bank to shrink and the ground surface to literally fall. And that's a practice that has to stop so that we could use this groundwater banking system to make up for the absence of dams. All right, so here is your next question, okay? California's breadbasket of agriculture for things like grapes, nuts, and plums, these are all high value crops, will suffer in the future because of what? Okay, A, there's not enough water in Northern California. Again, that's probably not too likely. Remember that precipitation doesn't really change that much. B, agricultural lands will be paved over to build houses. Well, that one actually might happen, but you saw my estimates of the demography in the future for that. It will be too hot in the summer and the plants will wilt. It'll be too warm for farm workers to pick the crops, and winter temperatures will be too high. Okay, so those are some of your questions to deal with. Now, the answer that I was looking at, there's truth in essentially all of these things except the first one. But the one that really is the kicker for California agriculture is the last question on here. Winter temperatures will be too high. And that has a huge impact on so-called on stone fruits of various sorts, plants that need a certain amount of winter chill in order to set the fruit. And that's true for nuts. It's true for things like plums and apricots and so forth. When I moved here, years ago, I remember California apricots being so heavenly. And so we planted some apricot trees and we got a crop every 5 years or something like that, because it just wasn't cold enough in Poway to set the fruit crop. So anyway, that's the key issue. So here you go, okay, the trajectory number 6 is agriculture. This is a map of the major habitats of the Central Valley and Coast Ranges in Central California. And you can see there's a lot of agricultural land, there's a lot of grassland and hay and pasture lands as well. And then this is the change in water availability. And of course, these are all negative numbers, okay? The hot color, really hot colors are really substantial reductions in the available water. And so here you see the Central Valley, the same mapped area, two different model scenarios, one more severe basically than the other one, but it doesn't really matter, okay? In all cases, the Central Valley dries out. There's just not going to be that much water around. And so that means that irrigation is likely to have to continue substantially or to increase substantially in order to make up for the natural increase in aridity, you know, of our agricultural breadbasket. This has an effect also on these winter temperatures that I mentioned. So this is the chill hours, how many hours it takes to set the fruit, you know, potentially of things like plums and apricots and so forth, grapes, nuts. This is the 1950 map, okay, where we had somewhere in the order of 1,500 chill hours. So it got cold in the wintertime, and that meant that the whole Central Valley was a good place to grow these various kinds of stone fruits that need cold winter conditions. But you see by the end of the century that we're down to somewhere between no chill hours to maybe 500 or so. And it turns out this number is strongly correlated to the kinds of fruits and nuts that can be grown. Now, it could be that genetic manipulation can help with this a little bit to increase the, or to allow plants to set fruit with fewer chill hours. But fundamentally, the whole Central Valley is becoming too warm to be able to grow a lot of the traditional crops that we have today, that are, by the way, the source of just enormous wealth to California. Okay, one thing that might hit close to us kind of urban types is wine. And wine is also undergoing a massive transition. So this is a map of where you could grow wine grapes decently today, okay? The dark blue colors are the number of suitable years when you can get a good quality wine grape. And so that's 1 year, not very good, okay? Most of the time, in 24-year span, you're gonna have 1 year of being able to get a good wine grape. You can see that in California, we have hot colors, which indicate that almost every year will produce a good wine quality grape. But here's the future, okay? And the future suggests that the good wine quality is all going up to Oregon and Washington. And then really, and California, on the other hand, becomes much more difficult to be able to grow a good quality wine grape in the future. I used to live on Cape Cod, and surprise, surprise, that's also going to be a place where you could get a good wine grape, according to future climatologies. And I can tell you that when Teresa and I lived on Cape Cod, there was the Cape Cod winery there, and it did not produce good wine. But, okay, in the future, near the end of the century, that might be the place to go. You know, move your Napa winery out to Massachusetts. Okay, trajectory number 7 is wildfire. This is, I think, the Cedar Fire in 2003. You can see all the smoke being blown out to sea. Fire being burned, of course, is bad news, but there are other fire impacts too. So one of them is the trajectory of where fires are going to be and how severe they're going to be. So this is an interesting statistic. VLFs are very large fires. We've had lots of these very recently. And the notion is you can see the mean number of very large fires for the recent past. Here's the mid-century, and here's the relative change between these two maps. And the key point is that there are really substantial changes, increases in the amount of fire activity in the West overall, with an increase by somewhere between 75 to 300% over what it is today by later part of this century. And you can see that that's really true in the Rocky Mountain states, but it's also true up here in the Sierra Nevada, Northern California, because that's where our forests principally are. Okay. Three different scenarios. Don't believe any of them too specifically, but the general pattern is the key issue. So you can see that the areas that tend to get burned in the future, where this +4 is 400% of today, is basically the Sierra Nevada. It's this area that gets wet enough to grow a forest. And that will be the place that will burn in the future. It burns now, but it will burn in these big fires in the future too. So one of the consequences of that is smoke impacts, okay? That being burned is one thing, but living with a dense blanket of this kind of smoke over you that hangs for weeks and weeks is really bad news for people's health. And I think for things like property values and other things. Nobody really wants to live in a haze of smoke all the time. This is the Malibu fire, the Woolsey fire from a couple of years ago. So air pollution, it turns out, also extends anyway, even without fire impacts. So this is some trends in air pollution. The maps don't look wildly different. This is something called PM 2.5. This is the smallest particles of soot that are the most dangerous to us from a health standpoint, because they get lodged in our lungs well. And you can see that the future trends are for, well, particularly here in the Salinas Valley, we see more of this fine particulate pollution because of greater urbanization there. But however, this particular map didn't take urbanization into effect. This was without any population change. So this change in smoke impacts or in soot impacts is primarily because of increased temperature and decreased rainfall. Okay. Okay, it turns out, I forgot I left these slides in here, that in the future, we'll also see increases in ozone. This are just two different maps that kind of give some flavor of this. Based upon climatologies, we'd expect that, for example, the Bay Area here will see more ozone impacts in the future. And the main thing for that is that because the climatology is a little warmer and there's less rainfall. And so you end up with more ozone buildup. But if we handle, okay, the climatology and the emission reductions, okay, we can actually drive down the ozone very substantially by doing things within the state, you know, by dealing with ozone sources in our own state. But you have this big red zone out here. What's all that about? That turns out that's Asian pollution. So that is pollution that has come across the North Pacific from China and Eurasia and is impacting our own coastal area. So this gives you one of these flavors about why this is a global problem. You know, we can deal with things at home, but we'll also have to deal with far field impacts that come from elsewhere if they don't handle in this case, ozone impacts in the future. Okay, trajectory number 8. We're closing in. Remember, there's 9 of these things. This is California's ecosystems. And so what is going to happen to the environment of the state? Okay, so here is your last question, or second to the last question, I think. In the future, coastal redwood trees will shrink their range in the north and maintain their range to the north, to shrink their range in the south and maintain their range in the north, die out everywhere, become extinct in California, be fine everywhere in their current range, or move inland to the Sierra Nevada. What do you think about that one? Fortunately, it's not number 2. We still have redwood trees in the future. But it turns out that actually the principal one is this top question. Okay, so that the redwood trees will be moving around, and in fact, a lot of plants in California will also be on the move. So if you could show the Emma, if you could show the total from that. I don't know. Ah, okay, all right, very good for everybody. Yeah, so we'll go on. So here is, for example, a couple of different models this is the current vegetation, and these are the different kinds of plants that are involved. And then these are two different models for the middle of the century, 2060, so 40 years from now or so. And there's many changes here that are worthwhile pointing out. I'll point out two of them. One is you can see the desert scrub out here. There's a desert scrub. There's a little bit of it in the southern San Joaquin Valley. But in some of these models, the southern San Joaquin really dries out. I've mentioned that before. And so that gets replaced by desert scrub kind of habitat. Another notable one is this blue stuff up here. The blue stuff is, I think they're lodgepole pines up in the high Sierras. And you can see that in both of these future scenarios, it looks like the lodgepole pine habitat shrinks somewhat in the future. That's also true, for example, for Doug fir up here in the northern coastal area. So the plants are on the move. Here's the redwoods, mentioned that, okay. So this is the North Coast. This is Humboldt County up here, up in northernmost California. And then this is the Bay Area. The red intervals are contraction in the habitat. So the trees are gonna leave, basically. And so the Santa Cruz Mountains, which currently has a big redwood forest on it, quite a lot of it got burned this year. But anyway, that is shrinking habitat. Probably be a lot fewer redwood trees up there in the future. And in fact, that's true throughout the whole, sort of central California area, up just north of San Francisco Bay, that fundamentally redwood habitat is disappearing there. But you'll notice that in the scenarios for Humboldt County, Northern California, which is where like Redwood National Forest is and so forth, this area will still have redwood trees in it by the end of the century. Here's another one, blue oak. Blue oaks are magnificent trees. These were one of the principal food crop plants for California Indians. And this is a sort of mid-level projection of where we would have blue oaks. And then you can see kind of what blue oak habitat is likely to be like near the end of the century. And this is change in drought frequency. How frequently are we going to have droughts that will do bad things to these trees? And basically the southern San Joaquin Valley and the Coast Range is basically becoming non-blue oak habitat. So the trees are also shifting northward. Here's another one. So I spent a lot of time out in the Mojave Desert. And so here we have the historical kind of desert habitat. And you can see classic desert out here in the Colorado Desert, the Mojave Desert, and so forth, shown here in red. That's today. But then scenarios into the future. Okay, a number of different climate simulations, different timescales here. But the very overriding pattern throughout this is that this classic desert habitat goes away. And you think, what? How is that possible? It's getting hotter, drier, and so forth. Shouldn't there be, expansion of desert rather than contraction of it? You'll notice that what replaces the classic modern desert are herbaceous perennials. So these are like grasses and things like little belly flowers and stuff like that. And you may hearken back to an earlier slide where I pointed out that there might end up being more summer rainfall in California, in Southern California in the future. And one of the drivers, one of the things that will do is to create more herbaceous perennials in what are currently abject deserts. Okay, and then the last, I think this is the last one that I got on this, is about ticks. This is not California, but you can see where we used to have Lyme disease ticks. I used to live here in Massachusetts, which is why I tossed this slide in there. But as we run into the future, you can see that the valleys along the Mississippi River also become a tick habitat. And so that some of our pest species are also changing. And you may have heard about this with respect to some disease organisms too, like yellow fever or what we think of as sort of tropical diseases today. Okay. Oh, yeah. And then the last sort of ecological change I'm going to talk about are range shifts in birds. So you can go and look at Audubon's site for this, and they have lots of these beautiful little maps showing where different bird habitats are going to change. This is the cactus wren, classic desert species, and its range is classically, here in the southwestern deserts, but this is all shrinking habitat. Okay, it says stable or slightly worsening, but the habitat is expanding massively towards the north, and likewise into the southern part of the San Joaquin Valley, and so we may end up with cactus wrens, down here in Santa Barbara and places like that. And then this one's kind of interesting. This is the California quail. The California quail is rapidly becoming an Oregon quail. So you can see that the red areas are all range lost, and range gained, on the other hand, is here in Southern Oregon. We'll still have California quail. They'll be in the coastal strip and maybe up higher in the Sierra Nevada. But their habitat is definitely shrinking in California. Okay. All right, trajectory number 9, my last, second to the last slide here is activism, okay? This is Jane Fonda being arrested for being, I think it was the Extinction Rebellion, if I'm not mistaken. This kind of idea that, that we are doomed basically in the very near term because of climate change. And this brings up my very last question for you, okay? So, is Jane Fonda right? Are we as a species doomed in 16 years? That's what the Extinction Rebellion people have been saying. Doomed in 24 years, 80 years, 100 years, or just generally fine? How optimistic are you? So that's the question. So tally up your votes. And by the way, doomed is kind of non-scientific language, obviously. What I mean is, really severe impacts on human society to the point that potentially there is social disorder and collapse. So anyway, if you could, Emma, if you could show the votes on that one. I'm curious to see how optimistic or not my audience is. Okay, well, there are some doomed in 80 to 100 years. Well, okay. I'd say that on the whole, that we're not doomed. That we're not necessarily fine, but that you can see all these sort of trajectories that I've talked about. A lot of them have what we might consider as negative impacts because they represent change for us, right? And change in the environment, these species all moving around and stuff like that. But remember that we're looking over a relatively long, from a human standpoint, time frame, and so that that many of these sorts of trends can be mitigated in various ways. All right, so here's two conclusion slides. The first is that I think that it's very clear that we are on our way towards a larger human population in the state, and this has been going on since before I was born. And that means that we do things like we'll probably have more energy intensive suburban and more water intensive needs and things like that. We'll end up with more heat stress. That seems to be inevitable if we keep on going down this road of burning fossil fuels extensively. This idea of a flashy future means more flash floods, more heavy rainfall, more floods of various sorts because of these atmospheric rivers, and more rain relative to snow with that consequent impact on water storage. Sea level is increasing, no doubt about it, not by a lot, however, but we still have these storm surges to worry about. And so even relatively modest sea level changes will still have big impacts on the coast. And we can fix some of those things, okay, depending upon how we treat coastal property. And this is kind of an ongoing debate. People who own houses on the coast, of course, they don't want to lose them, but they also don't want to pay exorbitant rates for insurance, or maybe they can't insure them anymore. Some more trends. Okay, one is that it seems like California salmon, anyway, We're valiantly trying to protect them. There's lots of efforts to try to keep them around because of their cultural value to everybody, basically. But the natural populations are likely to become extinct by the middle of the century. Here, by the way, not in Arizona, not in Oregon or Washington or Seattle or places like that. You know, the salmon aren't going to become extinct. They're just going to disappear from California. Agricultural lands are, warming also gets rid of our snowpack. This is bad news from this water storage standpoint. But if we think about storing that water underground and managing that water as groundwater banks, then the impact might be a lot less than it could be if we just have to deal with dams in the future. Agricultural lands become drier. This is a big problem for many of the current crops that are cash crops in California agriculture. I think California wineries are going to be restricted right to the coastal strip, but really go off and invest in those Massachusetts properties. Buy up right now, you know, you can have your wineries long into the future. Smoke and fire impacts are likely to grow. And I think this is particularly the case in Northern California, not so much of an issue for us, although we still have fires down here, of course, and they can be catastrophic. But I predict that in the future, because of this increase in very large fires, that the smoke problem will be really the big issue. Because that doesn't affect just the area that is being burned, it affects very large swaths of the northern part of the state that are going to become, at least seasonally, potentially unlivable. And where people who have health problems, particularly asthma and things like that, may really not want to be there in the summer. So right now we have snowbirds, people escaping you know, the cold winters in Minnesota or something like that. There may be a similar kind of thing, you know, for escaping fire, smoke impacts. The deserts will expand. Plants and animals are on the move, and including a lot of iconic species. And that's I don't think is either, well, I don't know. It depends upon your kind of attitude about how environmental change, what that really means for us. I think it's very interesting that it's going on, but very few of these species are likely to become actually extinct, except maybe as local populations. So there you go, that's my slideshow. And I think that maybe I will just get out of this. Let's see. I can end share screen maybe.
Yes. Thank you. Thank you so much, Dr. Norris. That was jam-packed with information, and we have